for session one, today's session is that we'll be exploring what is deep learning, why it is so popular, why it is so powerful, why it is gaining so much of limelight across the globe. What tools are available for you in terms of programming languages, in terms of the computation power, in terms of the data sets, what are the various use cases in which where you can apply deep learning. And those use cases, I'm sure you are aware of that. There is no dearth of use cases. There is no dearth of domains or the areas where we can implement them. And then how can you learn deep learning without impacting much of your day-to-day activities? And believe me, honestly, it's not an easy task. Let me be very honest with you. There's no magic bullet that okay, fine. You will take this series of 9 sessions and you will become an expert at deep learning. No, you won't. For that, you will have to practice a lot. With that being said, with the amount of research happening in this field, nobody can be, barring a few guys like Ian Goodfellow or Professor Fisheli or Professor Andrew Yang, barring few individuals on the earth, all of us are students only. Yeah, so that has to be kept in mind here. Okay, let's start. So first of all, we'll understand what is deep learning. Yeah. Now, AI is not a new thing. Artificial intelligence is nothing new. We have been creating automated solutions for a long time, decades and decades. Automation for machinery, automation for manufacturing, automation for customer checkout. Automation is everywhere. And all of that is called as artificial intelligence. So please don't think that AI is a new field. No, it is not. It has been in existence for a very long period. The difference is that it has gained popularity now. When I say popularity, I mean we have now tools, we now have technologies, we have computation power, we have cloud, we have means to communicate and share the thoughts. So just think about 90s, right? When we did not have social media or LinkedIn or this webinar itself, where we are connecting from all parts of the globe in different time zones, right? Then it would have sound quite novel, but it is not. Then comes, the classical machine learning that we always have. Like for examples are regression and decision trees and support vector machines and gradient boosting and random forest, all those machine learning algorithms, they are again not new. Those algorithms have been researched, have been discovered a long time back. So what is the difference between machine learning and traditional software engineering? I'm sure most of you will be aware of that. Let me spend a minute on that. I'll share my 2 cents with you. In traditional software engineering, whenever we have to code, we have to create a particular functionality, we write a piece of code for that, right? That if this condition, then do this, if this condition, then do this. And we have our set of codes, we initialize variables, we set their values, the counters are reset during the for loops, while loops, right? That is a traditional software engineering that we have. In machine learning, we do not hard code or we do not code, that functionality. We allow the algorithm to learn that pattern, to learn from the history. For example, if a customer, traditional customer analytics is one of the hottest field. The way a customer behaves, the way a customer shops, the price point a customer believes in, the category a customer shops in, day shopper, weekend shopper, online shopper, offline shopper, all sort of those parameters, that is the history of a customer. So the algorithm, it understands, it learns those patterns and then take a call. Fair enough. What makes a difference? If the customer pattern changes, customer lifestyle changes from a bachelor to a married person to a family with kids, the customer's spending patterns will change because the lives has changed, right? So you need not recode again everything from scratch. You have to fed You have to feed the new set of data to the algorithm, and algorithm will again learn those patterns. That is the advantage that we have. That is the power we have, that depending on the history, we can do many things, right? And we need not code again. Again, in software, in traditional software, you will be facing an issue that how to tackle a particular issue, how to tackle a particular problem. Over here, you have the entire history of data to support you. Then came deep learning. Now again, we started today that deep learning or AI is nothing new. So deep learning in regular terms, it most of the time it refers to neural networks, right? Uh, the neural networks, you must have heard, read podcasts, or in a blog post you must have read, or your colleagues might have told you that they behave, or they are similar to the way a human thinks, our human brain works. Okay, are they truly in that way? That is the question that we have in a mind. So long story short, the idea is from a human neuron, but it is not the way our brain behaves. Our brain is much more powerful than the levels of deep learning we have, or the levels of deep learning I expect that we will have in future. Now, with that in mind, where comes data science? Where this data science or data scientist? Where do they fit in? The data scientists that we have, or the data science as a field in itself, is an amalgamation of multiple fields, multiple topics: mathematics, statistics, coding. That is always there, but a small request, a small suggestion, a small tip for the budding data scientist, people who are learning, who are yet to have their journey, or who have started the journey. Please do not ignore business world. Do not ignore the business problem. Do not ignore the SME knowledge, the subject matter expert knowledge. Do not ignore the domain understanding. Because ultimately, if your deep learning model, a machine learning model, doesn't matter, it has 99 plus accuracy. If it is not implemented in the real world, if it is not solving the business problem, it is of no use. And business problem essentially revolves around two age-old things. Either you are increasing revenue or you are decreasing the cost, right? So your model should be solving those problems. So a 75% accurate model which is implemented is much better than a 98% accurate model which is not implemented. So please pay attention to that. So uh, deep learning is a subset, or you can say that it has learned, it has transferred, it has you know taken a lot of understanding from the classical machine learning algorithms, because they have been in progress or in practice for a longer duration. Yeah, the project plans, or the implementation of them, or the optimization and operationalization of them in the production environment, that is a resource information. Yeah. So it all started with the machine learning, correct? And these are type of machine learning algorithms that you have with you. Machine learning comes broadly in two flavors, right? You have your supervised learning algorithms, you have your unsupervised learning algorithms, and then there is semi-supervised. Okay, so you know a list of algorithms over here. It is just for reference, but you have your regression, clustering, market basket analysis, recommendation engines, principal component analysis. Many algorithms are there, right? And we study them in our textbooks. We study them in online courses. Okay, so again, a tip for you, a suggestion to you: please do not directly jump into deep learning. Do not directly start with neural networks. It is always advisable to have a background in traditional classical machine learning, because that will allow you a firm standing to understand those deep learning concepts. again, deep learning concepts are not straightforward again. There is a lot of powers, a lot of forces, they come together to create a solution, right? To create a fully connected network which can be used. Now, that's why I would always request all of you to spend some amount of time, in fact, an appreciable amount of time on classical machine learning algorithms too. Many times, students, they approach me that we want to study with deep learning, but we do not have a background on classical machine learning. My request, my advice to all of them is always that do not jump directly to deep learning. Yeah. Okay. Now, what is a typical neural network? How does it look like? This is a typical neural network. It will look a very simplistic version. Many times we feel that what is the meaning of deep? Do we have what is the exact meaning of deep? So deep is nothing but the hidden layers that you have. So a neural network will essentially have three types of layers: input layers, output layers, hidden layers. Input, as the name signifies, where you will enter your input data. Now your input data will be data. When I say data, your data can be structured and unstructured. Structured data, easy to understand, row column, traditional data that we have, right? So you have your let me try to draw something for you. Yeah, you have your customer ID, you have your ID, you have your name, you have your age, you have your salary, right? And then you have 1, 2, 3, 4, all of that, and then you will have data. Okay, fantastic. That is your structured data. Easy to understand, easy to decipher. The world has been using it for a long time. You have your machine learning algorithms, you have your SQL queries, Tableau, Power BI, Cognos dashboards, deciphering this data only, right? Representing that data into dashboards and reports and various form of visualizations. Good. Then comes your unstructured data. Unstructured data is the data that is generated every day, every second. Even the session right now, it is again unstructured data. So what is unstructured data? It is text, image, audio, and video. Now, what I request you to appreciate is that our computers, our CPUs, they do not understand images or text or videos or audios. They understand maths, they understand integers, and that too binary, right? So all of that data, the unstructured data, has to be converted to maths. Now, to give you a very small example to understand, which is very practical too, any image can be represented in the form of pixels, right? Each pixel, if it is a colored photograph, it can be represented into RGB values, red, green, and blue. And each RGB value, if you remember, it will range from 0 to 255. That means each image can be represented into integers. That means your data can be represented into a mathematical format. And that means you can feed it to your any algorithm, any mathematical algorithm. That you feed to your neural network from here. Just hold on. Okay, that will feed your neural network from here. Then comes your hidden layers. So hidden layers are nothing but where hidden layers are the layers where actual calculation will take place. Okay, your calculation in terms of the algorithms, in terms of those input data sets, they have to be added, subtracted, multiplied. There will be some statistical algorithm on top of that. That will be your hidden layer. That is over here, right? And then comes your output layer. So output layer, easy to understand. It will be an output that you will receive. Okay. So depending on the use case that you have, your output will change. object detection or image classification or sentiment analysis. We'll cover those use cases in detail, but that whatever your business problem is, that will be your output. Then what does this deep means? Deep, it refers to the depth of your neural network, the hidden layers in your neural network. Okay. At the same time, if you see over here, these neurons, which are there in yellow, right? These are the neurons. I'll come to neurons. What is a neuron? But you can just think of them right now as a mathematical block, as a box in which an input value is given. It gives you an output, simply. Yeah. That is a neuron, and a hidden layer, they will be your heart and brain of your neural network. But a very normal and commonplace mistake that we always make is, does it matter that how many hidden layers we have, and if I keep on increasing my number of hidden layers, will it to make my network stronger, more accurate, more robust, more stable? I'm sorry to say, no, it does not. So you should not have a very simplistic network with only a layer or two hidden layers. Yeah. But at the same time, if you have 100 hidden layers, it does not mean that your network's accuracy will increase. No, unfortunately, it does not. Sometimes it might also result into decreasing the accuracy. Okay. So please be clear that the number of hidden layers or the number of hidden neurons, they are directly not proportional to your accuracy. Yes, it does increase. Okay, but honestly, for our most of the real world problems, 3 or 4 or 5 layers or hidden layers are fantastically well. And let me admit one more thing to you. Most of the time in practical business world problems, we do not design our networks too. We do most of the time we do sort of a transfer learning where we take a pre-trained network. In subsequent sessions, we will be covering a lot of these details. But just to give you an idea, network design is an art in itself, right? So most of the time you will see in the industry that networks or the network architectures which have been explored and created by Facebook, Amazons, and Googles of the world, or research field, we use them. Inception V3, AlexNet, GoogleNet, LayNet, all of that. Those networks are most of the time used. Yeah. Okay. So with that in mind, let's move to what is a perceptron. So perceptron, it is a function which maps its input over here. You can see over here, inputs, or let's say input X, which is multiplied with the respective weight coefficients over here. Okay. Then you do something over here, weighted sum, and then you will have, you will get an output. So basically, it's a function, you can say. Okay. I have not shown bias over here. There's also a term called bias, which is also added. But most of the time, you can understand that, like in this neuron, which I was referring to, some mathematical entities, some mathematical values, they are called tensors. You can understand like a matrix, right? So a matrix of values will enter the respective weights, and then we do our mathematics, our magic inside the function, right? And then we will give an output. So essentially it means that basis the input values, how much this input value is good enough to determine an output for me. Long story short, this is the building block of your neural network. This is the atom from which this entire organism is built. Okay, this is the atom. The entire calculation, it takes place inside your neuron. Okay. That being said, so that was more of a neural network structure. What do you do with neural networks? The type of hidden layers, how the neurons, and we will be exploring these building blocks in much detail. Okay, how will you design your neural network from scratch? How will you create your neural network from scratch? But don't worry on one thing. Uh, do you have to do all the maths by yourself from scratch? Fortunately, no. Our libraries, our packages, they are very robust. They do all the math for us, and that's why we are quite fortunate to have all those packages, etc. Yeah. Now, then why is deep learning so popular nowadays, right? So our traditional machine learning algorithms, they have a few limitations. Our regression and decision trees, they they many times they struggle to find those insights and patterns in the unstructured data. Okay, uh, the data that we have, the text data, the images data, the videos, audios, all of that data that we discuss, the data is very cryptic, that it is very difficult to decipher. Because imagine, like I was talking about images data, where you have pixel by pixel values. For text data, you will have words. Words means alphabets. That means you have to represent those words into vector space diagram. Your videos, they are a combination of both audios and pictures, right? In videos, you have frames per second. So ultimately, if you break your video, you will get image and you'll get audio. And what it does, an audio has to be superimposed on top of images so that you can get videos, right? In layman's term, it will mean that if you have to analyze that for our classical machine learning algorithms, that becomes a bit of challenge. I'm not saying they cannot do that. They can. They do, in fact. In subsequent sessions, I will be sharing those differences in accuracy parameters also. That if I analyze a same audio file with my regression or decision trees, I will be getting 46, 48, 49% of accuracy. The moment I have something a deep learning algorithm, accuracy it exceeds beyond 70%, right? So they struggle to find the patterns, and the reason is that, first of all, the data size that is generated is humongous, right? And secondly, our algorithms are not designed or not meant for those purposes. Over here, deep learning helps us to uncover and understand those patterns. Okay. Um, the tools that are available to you. Okay. So if you think about a typical machine learning project, your 60-70% of the time will go spent is dedicated to data mining and data cleaning only. Honestly, it is very difficult to get a representative data set. People who are working in the data industry, be it database or data analysis or machine learning, you will be knowing that uh, getting the data or getting the correct source of data is very difficult. Getting the access and all of that, those maze of permissions is quite difficult to clear. But even once you get the data is seldom clean. In your date fields, you will have text. In your name, you will have integers. Your integers will have names and all of that, right? There will be null values, outliers, NAs. Your data will be very dirty. So you'll spending your 60-70% of the time in in data cleaning itself. Okay, that follows by your modeling and your finally wherever you are going to implement that. So modeling, it is the most what you call the lucrative part, the most interesting bit where we all are interested that let's create a model. So let me share one more practical insight with you. We do not create a machine learning model every month. Creating a machine learning model, it takes time, it takes resources, it takes a huge amount of dedication. That's why we do not create machine learning models every day. The second thing is, over here I would like to clarify a few differences between traditional machine learning and deep learning. So your traditional machine learning algorithms, you can call them as a shallow neural network because they have only one input and one output traditionally, or maybe one hidden layer. Whereas for your deep learning algorithms, they have hidden layers, right? Your machine learning algorithms, they require human intervention to detect the significant attributes. That means which are the significant variables to make a prediction. Whereas for deep learning, it works on itself. It offers end-to-end problem solutions. Whereas in our typical machine learning algorithms, the tasks are divided into small portions, right? And then together they form a combined solution. And many times you do need human intervention to identify those variables. Your machine learning, it can work on our CPUs, on our laptops, on our computers. But for deep learning, most of the time it is advisable to have a GPU, right? Or if you have a smaller data set, you can work on your systems also. But for our business problems where we can have a huge amount of data, you will require higher computation power. In terms of training time also, deep learning algorithms, they take more time as compared to machine learning algorithms. But that being said, appreciating these core differences between machine learning and deep learning, the process it remains the same. So rest be assured, the process of creating a solution, it remains the same. Because again, deep learning is nothing but it is from machine learning only that you have your data, you feed it to your network or to algorithm, and it understands, it learns the patterns, and then it is used to make the predictions. That principle, it is same, and that is why typical project architecture like this one, or a typical project process, let me put it this way, it will remain the same, right? Over here also, you'll be spending too much time on your data discovery and data cleaning. So a word of advice for all the all the students: spend some time on data engineering too. And honestly, data engineering uh, is one of those fields which is most of the time it is sometimes it is ignored. So the world does talk about deep learning or data science or machine learning, etc., etc. But that data engineering, that effort is many times ignored. For data engineer, getting the data, creating that pipeline, creating a data lake or database on which a data analyst or data scientist will work, right? That is the job of a data engineer. And many times we say that yes, it is possible. And believe me, it is much more difficult task. And one more point, in terms of if you want to explore the online resources, let's say, just do a quick comparison. The number of online resources or the number of online trainings or the materials available for data engineering will be less than data science. So my request will be that please spend time on data engineering too. Yeah. Okay. So the tools available to you. So there are n number of tools available to you. There's, for deep learning. If I strictly restrict this discussion to deep learning, so Python is becoming the go-to choice for deep learning. and thanks to TensorFlow, Keras, PyTorch, because they have been developed using Python. For traditional machine learning, we have our, again, open source tool for that. But for deep learning, Python is becoming the go-to choice. But the tools available for machine learning. There are many: Python, R, SAS, Weka, SPSS, all of that. I'm not saying that all these tools, they do not have libraries and packages for deep learning. They do have. They are well capable of handling and working on deep learning problem statements like MATLAB. MATLAB, it's a fantastic tool, fantastic libraries for, let's say if you want to do a image classification work, it can handle all of that end to end, from having a data pipeline to deep learning algorithm to creating a GUI too, right? But obviously it's not an open source tool. MATLAB, SAS, SPSS, they are not open source. You need to have a license to explore their full capabilities. But again, all these tools which I just not said, MATLAB or SPSS or SAS, their free university editions are available. Please feel free to download them, explore them, right? On the open source world, Python is becoming the most important language for deep learning perspective, right? Yeah. And then you have, all sort of your packages and libraries. Now again, a question is asked that should we go for TensorFlow, or should we go for Sonnet, or should we go for which language? Um, it depends on your level of comfortability. Okay, you might find that you know uh, most of these tools, so you will have data for them available too. You will have sample codes available at GitHub. Okay, the the data sets will be available. All of that will be is available to you. Okay, so let me spend a few minutes on that. So TensorFlow, it is developed by Google, right? One of the most powerful, popular, and widely used network library. Python is mostly used, but you are welcome to use C++, Java, C Sharp, JavaScript, Julia. You can use all of them. Okay. Uh, it is very popular. It can work on iOS and Android mobile devices too. So if Google is there, so there is Facebook. That's why you have PyTorch. Okay. So PyTorch, it operates with dynamically updated graphs, and that's why many times in many blogs you might study that for small projects and prototyping, PyTorch can be used. Okay, generally for cross-platform solutions, TensorFlow is used. Keras, Keras is a API-driven solution. Okay, one of the easiest deep learning frameworks, great for starters, fantastic for understanding and prototyping simple concepts. It is honestly, it is one of the most recommended libraries. So it's like a API driven solution, and you can do a lot of stuff on Keras very fast. Okay? So your massive models are reduced to a single line functions. That's why uh, on one hand it is a less configurable environment too. Then you have MaxNet, so it is Apache's MaxNet. Then you have Swift, Glon, many of them. Yeah. Processing power. That is a very interesting thing. Currently with the Google Colab or Azure, etc., you have uh, a huge amount of processing power available to you. So your AWS and Azure and Google Colab of the world, they offer you GPUs, their own GPUs at your disposal, and you can use them. You can train you're not no longer limited by your uh, the processing power of your CPU. Okay, please use them, right? you can simply upload your data onto a Google Drive, and you can drive on from there. Okay. Then comes, what are the use cases of deep learning? Where can you use deep learning? Plenty of uses. If I discount structured data use cases right now, the customer segmentation to predictive models, to recommendation models, to fraud detections, to propensity-based modeling, if I do not discuss them, if I strictly restrict myself to unstructured data. So if you have your images, your facial recognition, your image classification, the cliche being dog versus cat, right? So you want to classify, or you want to say that this image is good or bad. So all those image classifications, they can be done. Your object detection and object tracking, that in this particular image, do I see a man or a vehicle or a tree or a chair, or in this camera, can I track a particular person? Can I track a particular face? All those use cases, right? For your text data, your summary generation models, right? Sentiment analysis, okay? Those text data, they are a very rich source of insights. All your Facebook blogs, all your customer reviews, they are the sources of text data, right? So you can uncover huge amount of insights using your text data. For your audio, just think of a use case that if you are calling a call center, okay, and the call center employees, they took your call. At the end, they have to write a summary, right? That summary can be automated by using your text analysis, then, or a speech to text conversion that we have seen in on our WhatsApp, on our mobile phones. But speech to text conversion, it's it's not an easy task. There is a Google API for that, freely available to use, but think of a commercial application of that. Okay, your grammar check, your spell check, all of that entire data points, they are in the realm of deep learning use cases. Now, it goes back to the data set that you have. So text data, image data, audio data, videos data. Think from those perspective. Start from there, please. That what are the sources of these data sets? If you are a business, your customers will go to your Facebook page, will post their complaint, will post their appreciation. You will know that what they like, what they do not like. So if you manufacture mobile phones, right, you will know that the customer, they do not like the battery being so low in battery memory, or they like the resolution, right? From your video. So if a customer takes a picture of a faulty device and sends it to you, you would have to do a manual inspection of that. Think of it, if you can use a deep learning solution for that. So imagine that you are an electric or a water meter supplier. If the customer takes a snap of their electric meter and sends to you to take the reading, so instead of you taking the reading manually, if you have a deep learning algorithm, it takes a reading automatically and updates the system automatically in the background without any human intervention. Think of such use cases, right? So the use cases are immense. They are immense. Yeah. Now, the biggest question that always comes to our mind is that what can we do to learn deep learning? Is it very difficult? Is it too tough? What is the level of mathematics I should know? Do I need to understand and know a lot of statistics? My background is not from mathematics. My background is not from engineering. My background is commerce or literature. Can I enter that? Or I have not coded ever. What should I do? So please do not worry about those challenges. Yes, I do agree that a person from a traditional computer science background might have a small edge. The edge will be he or she, they will be more familiar with the concepts, the OOPS, the object oriented concepts. But again, they're not very difficult to understand. You can master them in few months of time. Statistics or mathematics, again, they are important. I'm not denying that. But the level of mathematics that you should know is not of that level of a PhD. So if you are planning to enter into a research-based, industry research-based field, then it might be more prudent for you to think of, okay, I should be a MSc in mathematics. But for our purposes, our practical applications, we do not have to be a master of mathematics. But again, you should know what is happening behind the scenes. Same goes for statistics also. Coding is required. Coding is required, obviously. That is a bread and butter. But the resources available are too wide, are into multiple formats. They're both paid and paid. So you have your online courses, Coursera, Udemy's, UDX, multiple courses are available online at YouTube for free, on these websites for paid. Specializations are there. 6 months, 8 months, 1 year. There are MSc and postgrad courses in that. The number of books available, they are too large. Many books are available. Do not get confused at which, or is it the best one, or should I take this, or should I not take this. Start with somewhere. You have to take the first step. You have to take that leap of faith and start with it. Okay, and then you can go ahead. GitHub is a very important source, right? GitHub is a very important source. So you can take all that GitHub, GitHub code repository. Practice. That is the key, right? And you cannot deny the importance of networking over here. So please be in contact with the the people who understand deep learning, whom you can follow for their work, for their uh, quotations, for the guidance from there. Okay, please be in the network of those people. LinkedIn is the best source for that. But one thing is very important. You have to take that very first step. Without that very first step, you will not land up anywhere. So do not hesitate. Do not be afraid. Do not think that it is totally, a field which is I cannot decipher that. No, it is not like that. There is solid mathematics behind each and every deep learning solution we have, and with all the libraries, all the cores that you have, you can understand, you can learn deep learning by putting good amount of effort on that. Efforts are important. Efforts you have to put. That taking the first step will be your decision. Okay.